Page 95, solving multiplication and division equations. Yes, ma'am?
Guess what? I found my math book. Guess who had it? Maddie.
Okay, so the other day we worked with addition and subtraction equations, and we worked through inverse operations where we always had to kind of focus on the opposite. For example, if I had x plus 4 is equal to a 9, what we had to make sure we did was to isolate the variable, because really what I needed to know was what x equals. And the only way I could do that was to do the opposite of what was happening on the same side as x. So here we're adding 4. The opposite would be to subtract 4. And I didn't just do that from the one side, but I would also do it to the other. X would equal 5. How did I know for sure that 5 was the solution to my equation, Joe? Yeah, I just basically plug in the 5 for x's, and then 5 plus 4 does equal 9, therefore we'll be in good shape. So it didn't take long to figure out that the opposite of addition was subtraction. The opposite of subtraction was addition. Now we're working through multiplication and division. So the opposite of multiplication will be division. The opposite of division will be multiplication. So it's just all a matter of trying to recognize what we're doing so that we can do the opposite. Now, in this particular equation, 9x equals 36. Obviously, our variable is x. What's currently happening to x? What's currently happening to it right now? Sarah? It's being multiplied by 9. Right? So the opposite will be to divide both sides by 9. Okay. Why does this isolate x? What is 9 divided by 9? 1. 1x is the same as saying x, right? How many x's do you see there? 1. So it's just like saying 1x. 36 divided by 9 is equal to 4. Plug it in. 9 times 4, does it equal 36? Absolutely. Any questions so far? y is equal to 27. Okay. So y is being multiplied by 10. The opposite will be to divide then by 10. We'll isolate y. Now, 27 divided by 10. A couple of options here. I don't mind either way. It is a power of 10 in which you're dividing, which if you want to use decimals, it's just a matter of moving the decimal. When you divide by 10, how many places would you move the decimal? Why 1, Raven? Only 1, 0. And if I divide, I move to the left, correct? So y would equal 2.7. And if you weren't sure, you could still set it up and do things the long way and say 2.7. Still the same thing. Now, some of you might prefer, when you see this written this way, when you see the division written that way, you may also recognize it as something else that we've talked about plenty of times before. What do we call that where our numerator is larger than the denominator? Josiah. And we usually turn improper fractions into what? Good. How many times can we fit 10 into 27? 2. And then that would give us 20. Take 20 from 27, how many are left? With the denominator remaining 10. 2 and 7/10 would also be the same thing. Isn't this 2 and 7/10 technically? So as far as preference is concerned, I really could care less what route you want to take. Okay? Sometimes maybe the fraction will be easier. Sometimes maybe the decimal will be easier. I'll let you choose. Here, try this one. 0.8 P is equal to 32. Okay, now we just said I can give you the option of working with either the decimal or the fraction. Sometimes you might not have much of a choice. What route is suggested here strongly? Decimal or fraction? I already have a decimal, so I might as well just go with it. Divide both sides by 0.8. Okay, now, if I were to set this up, I kind of know that there's a relationship between 32 and 8. Okay, now maybe you can figure that out in your head. Otherwise, if you need to set it up the long way, it'd be this. But I need to make sure also that I'm dividing by a whole number. So therefore, I would need to move that decimal. 8 into 32, 4. And then I got to cover to that 0. So P would equal 40. Okay. Any questions so far? Try another one like that. Sure. 2.5 G is equal to 17.5. Computation. All right. Dividing both by 2.5 and set up this away. I need to make sure that I'm dividing by a whole number. Therefore, if I move that decimal over one place instead of 2.5, now it's a 25 whole number. Got to do one place on the inside since I did one on the out. 25 into 175. Okay, I just said to Trinity, how many quarters would you fit into $1.75? And she said 7. And that gives us 175. G equals 7. Plug it in. You know, can you estimate even to determine if you're close enough? Sure. You know, 7 times 2 is 14. 7 times 3 would be 21. Somewhere in the middle of 14, 21, right, will give you what you're looking for. All right, any questions? Is it just early? You didn't have your coffee yet? I love 7th grade in the morning. So much different than in the afternoon.
Why?
Yeah, I mean, just so much more docile. Calm. Focused. More like it. Right, Joe? What do we got, Sarah? I else thought it was 8. Be honest. Be honest. Got a couple honest people in here. That's the most common mistake. You look at it and you say 40 and 5 got to be 8. Well, doesn't necessarily make sense if you plug it in. So let's take a closer look. Thank you for being the guinea pig, Sarah. What's happening to n? It's being divided by 5, right? The opposite of divided by 5? Multiplied by 5. So I'll show you why that isolates n. Fraction form, right? Fraction form, right? So if I multiply in fraction form, everything has to be in fraction form. Put a 5 in fraction form. 5 over 1. And then 40 times the 5. I don't need to put in fraction form because the 40 isn't in fraction form. So, isolates how? 5 and 5 both have 5 in common, right? N times 1 up top is n, right? N over 1, n. Therefore, isolated. All that trouble for that. Now, 40 times 5. 4 times 5 is 20, plus an extra 0, 200. 200 divided by 5 is 40. You have to go through the motions. You can't. You can use mental math, but it's much easier to make careless mistakes because your brain has been so conditioned to seeing 5 and 40 and immediately thinking 8. I don't think we immediately think 200 when we see 40 and 5, do we? Not necessarily. You're more apt to think 8. 8 over 5? Does that make sense? Is that equal to 40? What would 8 over 5 be equal to? 1 and 3/5. So 1 and 3/5 is equal to 40? No. 1.6 equal to 40? So just be careful. There you go. Try those. Q divided by 6. The opposite of divided by 6, Sarah? 4 times 6? Very good. A divided by 7 is 63. A is being divided by 7. The opposite of divided by 7? Multiply by 7. Okay. 21. 42 plus 2? 441. Okay. There you have it. You basically have to protect against yourself with this assignment. Okay, because if we're still thinking that maybe like A is equal to 9, when you see 63 and 7, have to go through the motions. You can't look at it and try and figure it out. Okay? And I'll accommodate you today, and I'll give you plenty of time to work on your assignments so that you don't feel rushed. Okay? So let's take a peek at the next worksheets for 2-7 and just kind of double check and make sure there's no tricks on there for you. Yeah, it doesn't look like they're giving you any positives and negatives and that kind of stuff, which wouldn't be out of the realm of what you could do, but just to be on the safe side. Your assignment will be worksheet 2-7, numbers 1 through 24. Take a peek at 1 through 12. What are they asking you to do for 1 through 12? Sarah.
State what the number given is a solution of multiple equations.
Very good. So they want a yes or no answer. Kind of nice. So 8c is equal to 80, and they're suggesting that c is equal to 10. So how do you know for sure if this is a solution or if this is not? Willie? Yeah, I'm going to take their suggestion. I'm going to take that 10. I'm going to plug it in. So 8 times the 10 they suggest. Does it give us 80? Therefore, yes. Okay. That's for 1 through 12. Any questions on 1 through 12? 13 through 24, you just have to solve them. So you do exactly what we've been doing in class. Find out what each variable equals. Okay, if they're multiplying, use division. If they're dividing, use multiplication. You can always, the second part of those directions say then check each solution. That'll be up to you. It'll be up to you to make sure you check it. Okay? A lot of people prefer the multiplication and division equations to the addition and subtraction. Easier to work with, easier to check. So please don't get careless.